then R over R times 10 to the third kilogram per meter cubed. That was the density. So the potential energy here, R, U sub R minus U sub little r is equal to negative integral R to big R. Okay, so the force of gravity, well, what we could do is we could use that equation that we developed. So for what is the force of gravity, is we're going to do F dotted into dr, right? So the force of gravity, I'm going to use the same equation that we got from last week for the force of gravity inside of our Earth. Okay, so it was what? So let's write that down. Force. Remember, it was 3gs divided by the density of the Earth, which was 5,496.966, and then the 10 to the third is for the kilogram, and this was the behavior of the R. Now, last week, when I calculated this, I was specifically interested in the G, the gravitational field. But the force of gravity is just simply the negative, because the direction-wise it's inward, and then times the mass of the second object. So if there's a person, we can call it M2. If there's a person inside of that planet, there'll be M2. So simply all we have to do now is to integrate this minus the integral of this thing. So again, this minus that minus is going to simply become a plus. So you're going to be left with UR minus U little r. And the two minuses are going to be plus. This is just a constant. So that's going to be 3GSM2 divided by, and then the 10 to the third, I can write this as 5.496966. And then inside of the integral, you're going to have the integral from R to big R of 4.73 R over R minus 2.9 R over big R squared dr. Okay, so then we could cancel, we could erase this. So we're left with, and then here the potential energy at R, I'm going to again use minus GMM over R. So minus GM Earth M2 over R, radius of the Earth, since we're applying this to the Earth. That's the U of R, minus GM Earth M2 over R, minus U sub little r is equal to 3GS mass 2 divided by 5.496966. Then the integral of this is 4.73 over radius of the Earth. And then the integral of that is R squared over 2. Now this was a repeating 3, right? Repeating 3 here. So R squared over 2 minus 2.9 over big R squared, radius of the Earth squared. And then the integral of R squared is going to be R cubed over 3. From little r to big R. And let's see here, we have negative GME M2 over RE. Okay, minus U sub R is equal to 3GS M2 over 5.49 6, and you're left with here, now if you put the radius of the Earth here, RE squared divided by RE, so you're left with 4.73 RE squared, so it's one of the RE's is going to cancel, divided by 2, minus, and then this one, RE cubed over RE squared, RE cubed over RE squared, so what is that? Again, just RE, right? 2.9 over 3 RE. And then you put this one in, negative 4.73 bar over 2 RE R squared. And then put this one in, so it'll be plus, because it'll be minus minus, plus 2.9 over 3 R cubed over RE squared. Okay, close the whole little bracket. Okay, so then what here? How could we simplify this so it won't look as bad? Well, this one you can just combine them. 4.733333 divided by 2 minus this one, 2.9 divided by 3 would be 1.3999. I'm going to simplify it, make it 1.40. So this is just 1.40. Radius of the Earth minus, and this one simplify that, 4.733333 divided by 2, so it'll be 2.367 over radius of the Earth R squared plus, and then 2.9 divided by 3, so 0.967 over R Earth squared R cubed. Okay, so it's, now again we can simplify it further by saying that this thing really, I can rewrite it, because remember G, the gravity of the surface is GME over radius of the Earth squared. So really I could, and that's equal to GS. So I could say here, square this and multiply it by radius of the Earth, and then this thing will become GS.